Now I will start the pumps in parallel, in series and compresses, that part. So we have already learned that pump can be basically two types. One will be centrifugal or dynamic or kinematic pump, kinematic, and another will be positive displacement. Okay, so they have their own characteristics, like say kinematic or centrifugal, basically centrifugal pump. Okay, so this pump is having limitation of head. Okay, you can see this Q and H curve, and positive displacement curve you have seen vertical. So in positive displacement pump, actually you are developing infinity head ideally, but practically it may not be possible. Gradually this vertical line will be moving towards this H side or H axis, and finally there will be some limitation of total amount of head. Now in some cases you need very high amount of flow rate. So in that case you can connect pumps in parallel. Okay. Then you can collect the whole water here. So total volume you are increasing. Volume increasing if parallel. If okay, but if you are connecting in series, one pump, 1, 2, 3, like this. Okay, so in that case 1, 2, 3. So total volume fixed, but head is added or increased. Okay, but parallel case total volume increasing, just every one pump is developing Q1, Q2, Q3, so Q1 plus Q2 plus Q3. But in this case head is added up, like say H1 plus H2 plus H3 total head. But here Q equals Q1 plus Q2 plus Q3. Okay, but in first case head is not changing almost. Second case flow rate is not changing. Flow rate will never change because you cannot destroy mass. Okay, so because we are assuming this is incompressible flow, water is, although compressibility there, okay, but what happens, we are not compressing at that level, so where significant compression can be observed. So in practical application we assume water is incompressible. So it is incompressible, then head equals H1 plus H2 plus H3, Q equals Q1 plus Q2 plus Q3 for two different cases. This is pump in series, pump in parallel. This is pump in pumps, I can say pumps in series. Okay, so both are having their advantages and disadvantages, basically head and flow rate multiplication. Okay, basic difference. Okay, pulsation, dampener and multiple cylinder. So what happens in reciprocating pump? In centrifugal pump or a screw type pump or positive displacement, like that pump I already explained. What happens in positive displacement pump? We have basically two types of positive displacement pump. One will be reciprocating type, another can be rotary type. Rotary type means like positive displacement pump. This is called I'll make this is rotor stator. Okay, so rotor stator, this is actually PCP or positive displacement pump. So normally PCP or positive displacement pump speed will be like 300 RPM, but in centrifugal pump the speed will be like 1400 to 3000 RPM about. And reciprocating pump, when you are talking about reciprocating, so because of a speed you cannot increase the pump speed at very high level. For example, if you have 10 stroke, 20 stroke, maybe 1 or 2 stroke per minute, 20 stroke, 100 stroke also maybe sometimes it will be too high. Okay, so 10-20 strokes or 10-20 times it is pushing and pulling, delivering fluid, that can be okay for reciprocating pump, maybe 10-20 RPM. Okay, so it will be around this one. But for rotary type, this is reciprocating type positive displacement pump. Okay, and rotary type, this is rotary type positive displacement pump. Okay, so reciprocating type pump is very slow speed, and rotary type speed will be little bit higher. Another difference is that reciprocating pump will give pressure pulses, but positive displacement rotary type screw type, that pump will give a continuous pressure. How? Let us say when piston is moving from A to B, fluid is getting sucked. Okay, so that time you are not developing any pressure. Okay. Again, when you are moving piston from B to A, from B end to A end, so you are increasing pressure, right? You are delivering that time. Okay, so that time what is happening? So one time you are getting very high pressure. Again, when piston is moving backward side, so you are not getting any pressure. So this time no pressure. Again you are getting pressure. So if you have one pressure measuring devices, let's say here, okay, pressure gauge is there. So what will happen when piston is moving from B to A, your pressure is increasing, so it will be showing pressure like this. When piston is moving A to B, okay, so B to A to B, sorry, A to B here, A to B, again this is B to A. Okay, B to A means you are getting pressure, A to B means you are not getting any pressure. So we are getting pulse, one time pressure, no pressure, no pressure, no pressure, pressure, no pressure. So pulse pressure we are getting. For example, your heart, human heart is working, like it is also giving pulse, right? It is also giving pulse like this. But your rotary type system, it is not giving that pulse. Now let us say in certain situation you are getting pulse, but you don't want that pulse, you want smooth flow, but you want all the benefit of positive displacement pump. Then what you do, you put some pulsation dampener. But in say in this case, if you are creating multiple cylinder, this is single cylinder, right? Single cylinder, single cylinder pump, and this single stroke also, single stroke or simplex. Okay, if you have simplex pump, you are delivering one time, another time you are not delivering, so you are getting pulsed flow. Now if you have double acting pump means like you have piston, you have one delivery valve, one suction valve, and this side also there will be one delivery valve, suction valve. So in that case actually your pulse profile will be like this: one time delivering, let's say A, or maybe A1, B1 I can make. So A1 delivering, but when piston is moving from A to B, okay, B that time is not delivering. Okay, so you are getting pulse like this. Now when piston moved at B, again moving in opposite direction, that time B is delivering. Okay, B1, then again A1 delivering. So continuously A1 delivering one time, B1 one time delivering. So now your pulse profile almost smooth, right? So first case, simplex case, you are getting only pulse, no pulse, pulse, no pulse. So now you are getting double stroke pump. In that case you are getting pulse, pulse, pulse. Still there is some variations. Now if I have multiple cylinders, let's say I create one system like this. Okay, I have one cylinder here. Okay, I have another cylinder here and connected here. I have another cylinder here connected here. So what is happening when this crank, connecting rod, you can see this connecting rod are moving in different direction, right? So when crank is rotating, so one piston delivering, another piston sucking. So in that case pulse profile will be like this. Let's say A1, B1, C1. I have 3 cylinder. So A1 is delivering, now B1 will be delivering, now C1 will be delivering, So A1, B1, C1. Now again A1 will be delivering. Now again B1 will be delivering. So pulse profile again become much smoother. Now if I have, instead of 3, I have many cylinders. So in that case, what will happen? Pulse profile will be like this. Okay. So you will get almost constant pulse. Okay. So if you have many cylinders, you are delivering total amount of fluid more, and you are getting almost pulse free delivery. But in some cases, you are not having that much of benefit of having multiple cylinder. In this case, what you do, you use pulsation dampener. So if you have only single cylinder, let's assume, okay, and you have piston here and piston rod here, piston rod or connecting rod, and here delivery valve, entry valve. So in that case, you are getting pulse like this. Okay. Now if I have one delivery side, I have one chamber with nitrogen filled. So chamber will be like this. Okay, chamber is like this, and this is nitrogen filled area, gas filled balloon, bladder, gas filled bladder. So what happens when delivery fluid will come? So this delivery fluid will be compressing this bladder. Okay, so this is called pulsation dampener. Okay, or they say pulsation accumulator, pressure accumulator, or it is called pressure accumulator or hydraulic accumulator. Okay, so what the pressure pulses are there, it will be dampening, or the pulses will be reduced. Okay, because this gas filled bladder will be absorbing the pulses and it will be delivering smooth flow. So inlet pressure pulses is like this, then outlet pulses will be like this. Okay, so it is smoothening, so that's why it's called pulsation dampener. Okay, in many cases this pulsation dampener is used for specific applications. Now let's solve one problem. Let's assume one radial flow impeller or centrifugal pump. Centrifugal pump. Okay, we have radial flow impeller, impeller A and impeller B, and impeller A is having diameter 1 feet and impeller B is having 2 feet, efficiency 70, 65, and N is given 1500, 3000. So calculation we have to do like this. Head ratio HA by HB you have to calculate. So head formula HA eta A U A square by 2G. You can remember the formula, and HB also eta B, similar formula, E B 2G. You means impeller speed. Okay, so HA by HB equals eta A by eta B, UA square UB square. 2G vanished, so eta A by eta B, UA omega A square RA square omega B square RA square RB square. Okay, so this value will be like this. Eta A means 0.7, 0.65, omega A 2n pi by 60, 2n pi by 60, 2n pi by 60 n A n B square RA by RB square. Okay, so RA by RB is given, A is given 1, B is 2. So this will be giving like this 0.7, 0.65, 1 by 2 into 1 by 2. So finally we are getting square 0.067. This is the answer.